to 30%.
So looking at when you look at two variable linear systems, you can also do a method called elimination. Now, admittedly, elimination can be used on more complex systems, but it's much easier to screw up. So we pretty much avoid it for the most part. So, but if you have that simple format where you have that ax plus by equals c, you can do elimination on it. The idea is you can treat it like a giant addition problem or a giant subtraction problem and eliminate one of your variables that way. Okay, and that's the way I usually think about it. I believe the book does it so it's always addition. I honestly do either addition or subtraction depending on what's going to work the easiest. Okay, because the one like this, what could I do? If I add them, it's going to eliminate the y's. So I typically put a symbol here, just in parentheses, say I'm adding everything in the line. What do you end up with on the left side of the equal sign? On the right? -8. So x is equal to? Then what? Plug it in, so you have 2 times your -2 plus y equals -1. So y is going to equal 3. You have -4 plus y equals -1. Add 4 to both sides. So you get -2, 3. Okay? Honestly, at the beginning, the book breaks it down into steps, but most people should be comfortable with this. Usually, this is the one that's liked better than the substitution method, but you need to be able to do both.
Do you, are you able to cancel out the ones without variables, or do you want to always cancel out the ones with variables?
The whole concept is you're eliminating the variable so you can solve for the other one.
Okay.
So you always want to get rid of one of your variables.
Okay.
Okay? So, excuse me. What if I have this equation? Can I just add these together and get rid of anything? No, so what do I need to do first? If I multiply the top one by 3, and you can denote that however you want. One way is just using the arrow and saying what you're doing. So you end up with 6x plus 3y is equal to 1. The bottom, I'm not going to change anything on. So then,
Why is it equal to 1? Yeah, shouldn't be.
3, thank you. Honestly, that's what ends up happening quite a lot of the time, is students will forget to multiply times what's the constant as well. They'll do the 2 coefficients and then not do the constant. Okay? So, do I want to add or subtract? Does it actually matter? No. If I add them, it'll eliminate the y. If I subtract them, I'm going to get rid of the x. Okay? So, since it doesn't matter, I'm probably just going to add. That's going to give me what on the left? Is equal to? So x would be equal to what? 3/4. So I'm going to take 3/4 and plug it back into either one of these. So 2 times the 3/4 plus y is equal to 1. So what do you get? Be -1/2, because over here I'm going to have 3 halves. So when I subtract 1.5 from 1, I'm going to get -1/2. So 3/4 and -1/2, and there's your answer. Okay, and that concept is actually the idea called they're equivalent systems, because as long as I'm multiplying every single bit of one of the equations times something, then that allows me to keep it the same and still use it. As long as I multiply everything in that equation. Okay, and that's honestly all this talks about. As long as you multiply by some constant and you multiply everything, they're the same system. They just look different. So if I want to solve this one, what would I have to do? Okay. So if I multiply the top by 2, what am I going to get?
6x plus 4y.
Equals 14 on the bottom.
Should we do -6?
I'm just going to subtract instead. You could do -6 and then add, and if you want to do it that way, fantastic. But I'm just going to multiply it by a +3 so that it gives me, and then I'll just subtract the 2 equations. Either way works. What's the rest of it? 15y is equal to 3. So then when I subtract this, the x is eliminated. What do I have for the y? Negative 11y. And for the constant? 11. So y is equal to negative 1. Plug that in, because you're dividing by negative 11, right? Plug that in, so I have 2x plus 5 times negative 1 is equal to 1. 2x minus 5 equals 1. So x is 3. So I have 3, negative 1 as my solution. Okay. Now, since we're talking about linear equations, we already talked about this a little bit before, but you're only going to have so many possible combinations. Since these are both lines, either you're going to have exactly one solution, which means you have two lines intersecting at one point, and their slopes are two different numbers. Okay. You can have infinitely many solutions. That happens if you have two lines that actually coincide or are identical, which means the slopes of the lines are equal, but they have the same y-intercept. Or you have no solutions. Again, the slopes are the same, they're parallel, but you have two different y-intercepts. Okay? Now, terminology-wise, you will need to just be able to describe your solutions a little bit as either consistent or inconsistent. Consistent graphs have a solution, inconsistent ones do not. Then consistent breaks down further into either independent or dependent. Infinite solutions are dependent. One solution is independent. Okay? So, looking at these. Obviously, graphs 1, 2, and 3 have coincide, parallel, and one solution. Which one, A, B, or C, will be the same line? A? Now remember, the slope is going to be drawn from, the slope means I would solve for y. So I'd move over the x, then divide by the coefficient. So what you want to look at is the coefficients. These will have the same slope because all I have to do is multiply this equation times negative 2 and give me the same numbers. But if I multiply 3 by negative 2, do I get 6? No, so this one doesn't work. This is actually parallel because these numbers are in ratio to each other, but these aren't. So this one are the parallel lines. So A is 2. C is this one because if I multiply by negative 2, that would match up. So these are the coincide, these are the parallel. This one then, well, the only thing left is that those have one solution.
So how do you know the difference between parallel and like the on top of each other?
Comes down to these numbers here.
Okay.
The constant is like your y-intercept.
So if it all equals 0, then it'd be the...
So if you can multiply this equation by any number, the whole thing, and get the other one, then they coincide.
Okay.
If you can multiply them times the same number and get the same x and y,
but the opposite.
but some other number, doesn't matter if it's the opposite, some other number for the constant here, then they're parallel.
Okay.
Okay? Okay. So, if I want to solve this system, what would I multiply by? Now, take the top one times 2. So that's going to give me what on top? Equals 6. On the bottom, stays the same. Add or subtract? Add. If you subtracted, you'd actually get 24 and 20. So you do need to add because they're the opposite signs. What do you end up getting on the left side of the equal sign?
0.
What do you get on the right? 11. So you're getting by eliminating all the variables, that alone gets you down to either parallel or no solution. By having a false statement, it means no solution. If you had 0 equals 0, then it would be parallel. Or it would be infinitely many, sorry. So this one is no solution. Then how would I describe that? Consistent or inconsistent? Inconsistent. Yeah?
What would happen if, like, say instead of an 11, that was like 12? So then, like...
Same thing, it just means the y-intercept would be different.
It'd be like 12 equals 0, but then you could, like, subtract 6. Oh, wait, never mind.
There you go. So, for this one, What do I want to multiply by?
Ugh.
8. Biggest least common denominator, essentially, to get rid of the denominators. If I multiply times 8, what am I going to get on top? Minus y is equal to negative 3. Here I have negative 4x plus y is equal to 3. So if I add those two together, what am I going to get? 0 and 0. So the idea is you have infinitely many solutions. That was a horrible infinity sign. Let's try that again.
It looks like a really awkward fish.
It's a little better. So, how would you describe the system? Consistent. And what?
Independent.
Which one? Dependent.
It is dependent. Why do you do that?
You guys said two different things. I never remember completely off the top of my head. So that's the one I never remember completely off the top of my head, so I'm going to look back. Yeah, dependent's right. I had to stop and think about it.
If they're dependent, then they're
The consistent and inconsistent, I remember. The dependent and independent, this is the only time you talk about it, so I don't always remember that in this context.
Well, like, if you think about it, like, dependent, the two lines are depending on each other in both the same way, but then the other ones, they're
It's a good way to think of it.
yeah.
Are there other contexts for independent and dependent?
Yeah.
I mean, we're just talking about variables in general, inputs and outputs. That's there, but the lines. See, I always think about it in terms of the x and the y value. Independent variable, dependent variable. When you're talking about the lines themselves, that's not where my mind goes instantly. It goes to the x, y instead. But yes, you got to know it. For this, solve the system. What would I want to do here?
Could you multiply the top of my triangle and the bottom of my
Yeah. Multiply by something to get rid of all the decimals.
bottom?
So what would you actually multiply to get rid of all the decimals? 100. Now I'm going to actually shortcut and do this in one step. I'm also going to get these so they match up.
So 200 and 300.
By 200 and by 300. That'll allow me to eliminate the x. So when I do that, the top is going to turn into what? 6x plus 8y is equal to 150. Okay? Because it's not 0.075. That would be 15. It's 0.75. On the bottom, you still have 6x. What do you have for the y? 18y. 270. Because this says 90% of 300. This is 75% of 200, right? If you think about it that way.
8%.
Subtract them. X goes away. What do you have in the coefficient on the y? And over here? Negative 120. So y is equal to 12. Okay? Then get your x. Go back to here. 0.02 times your x plus 0.06 times 12 equals 0.9. So what's 6 times 12? 72. So 0.06 times 12 is 0.72.
Could you plug those numbers back into the ones you multiplied from?
You can. The only issue that can arise because of that, you may have, if you screwed up going from here to here, that'll give you an error as well, and you may not realize it. Like this might work for that, but because you did it wrong there, you won't catch your mistake. Here then, subtract the 0.72, so 0.02x is equal to what? 0.18. And 0.18 divided by 0.02? 9. So you get 912. And how would you describe that system?
That would be in, yeah.
Yeah, consistent and independent. Okay. Yeah.
Would it still work if you plugged the 12 into one of the equations that you generated?
Yeah.
and multiplied?
But again, if you made a mistake somewhere, you're exasperating that mistake. You're making a second time because of it. Okay? But usually you want to plug it back into the original.
I just didn't know if it was
Yeah.
complicated.
So an airplane is flying into a headwind, travels 1,650 miles flying distance. between two cities in 3 hours and 18 minutes. On the return flight, the distance traveled is traveled in only 3 hours. Find the airspeed of the plane and the speed of the wind, assuming that both remain constant.
Well, both of the equations are going to be equal to the 1650 mile because it's the same distance.
All right, but the problem is what I want to do instead, I want to actually change it from 1650 miles. I want to get things as simple as possible. I want to find the airspeed of the plane and the wind speed. Those are going to be my variables. That means both of those are in terms of speed. So I need to change the 1650. Instead of dealing with that, I want to deal with the speed it took for both trips. Okay? So how would I change this 1650 into the actual miles per hour? Yeah, 1650 divided by, 1650 divided by the 3 hours, 18 minutes. Now how would I actually do 3 hours, 18 minutes? Yeah, plus 18 divided by 60. So then just make sure to put that in your denominator. What do you get when you take 1650 divided by 3 and then plus 18 60ths?
198 60ths.
No.
500.
500. Did you put parentheses around the denominator?
I was doing the 3. The one I did 180 over 60 plus 18 over 60. I was getting you a denominator for you.
Okay.
And then the division was next.
So you were in the middle of it. Okay. 1650 divided by, for the other one?
There's 3 hours.
Just 3 hours. Gives you 550. Okay, so those are your two speeds. So I'm going to set up these two equations. One with 500 miles per hour, one with 550. Now I want to take the plane and the wind speed. Now what am I doing with them to get the 550 miles per hour? So stop and think about it. The plane's going to be the same either way, right? It's just whether the wind is acting against it or acting with it.
Which does it give the way of the speed because one of them's going to be acting with it and the other's going to be
So logically, which one of these would be acting with it if these are speeds?
the one going back.
The 550, the one that's faster,
So
right?
you'd add that one and then subtract that one.
Right. The faster speed, you're going to add the wind to the plane speed. The slower speed, you're going to subtract it from. So then what can I do?
Add that.
You can add them. If I add these together, the W's are gone. You get what?
2G equals 1,000.
Is equals what?
1,050.
1,050.
No, I was right. 525.
Well, that's what P is equal to. That's not what I asked.
Now,
512. Now, what are the units on that? Miles per hour. And that's the what?
No, that's the plane speed.
That's the airspeed. 525 miles per hour winds, we're in trouble. Okay?
And then plug it back in.
So airspeed of plane or airspeed for the plane. Plug it back in. What am I going to get for W? 25. So 25 miles per hour is your wind speed. Okay. Questions on that one?
That's an airplane question without bearings.
Should like it then. We could add bearings into it,
Please
but that would
don't.
bring vectors
Please
back
don't.
into it.
Please don't.
So, find the point of equilibrium of the supply and demand equations here. So the point of equilibrium means I want to know, well, essentially what the x value is and what the p value is. Now you could do this substitution, but we want to do it with elimination. Now, the question becomes, can I actually do this the way it is, or do I need to rearrange it first?
You have to rearrange it.
Why?
Because the 81 is on the same side as the x, so you have to get
So?
I don't know why I ever solved this.
You don't actually have to rearrange it. Right now, the p's are on one side, right? The x's are on one side, and the constant's on one side. Okay? You have the two p's here, you have the two x's, and what are your two constants?
81
81 and 0. So you can actually just do this way. But would I add or subtract? Subtract, because that's going to eliminate P. Then I'm going to end up with what on the other side? You're subtracting, so these are going to add to each other essentially. Point what? 675 x. Then what?
Then you solve for x.
Solve for x. What do I do? You could subtract 81. I would actually just move the other over, because that's going to get rid of my negative signs entirely. Add the 0.675. Divide. You get 120. Plug in the 120. P is going to be equal to 1/8 times 120. What's 1/8 of 120? 15. So those are your two answers. Questions? P is probably price and X is number of units moved. Would be my guess.
Would you not make that a coordinate?
That's a good point. You could, but at the same time, the way it's written, it implies that P is your dependent variable. So if you describe P as the Y value, then yeah, you could. Because it says point of equilibrium, yeah, I'd give you that. Questions on any of it? Okay, the rest of the time is yours.